All right, everybody, welcome back. Today we're going to look at the impacts of molecular forces on certain properties that we see. So, why they matter in terms of states of matter is that as we look at our states of matter, gases are going to have very weak IMFs, and so they are not going to be held together by those intermolecular forces, compared to a solid that's going to have strong intermolecular forces, and they're going to be held more tightly together. Solids and liquids have those melting points and boiling points that are going to be higher than what is typically found as a gas. Intermolecular forces in the liquids, we see impacts with surface tension, viscosity, evaporation and condensation, boiling point, and then also we can talk about liquids being miscible versus immiscible. When we look at intermolecular forces in liquids and we look at surface tension will be increased if we have stronger intermolecular forces. So we can have something sitting on top of the water or bugs walking on water, and they're going to be able to walk on water, which has stronger intermolecular forces better, or rather they're going to be able to do it, but they would not be able to do that in oil. They would sink in because the intermolecular forces between the oil molecules is much less than what's between water molecules. We also see impacts on viscosity. So if the intermolecular forces are stronger, or if molecules are long entangled, which will also create more interactions, then we'll see increased viscosity of a material. Looking at evaporation and condensation, evaporation is going to be the moving of a liquid to a vapor, and so this is going to increase with surface area, it's going to increase with increased temperature, and also decreased intermolecular forces. So if you have lower intermolecular forces, then you're going to have more evaporation, and then you're also going to have increased vapor pressure, because you're going to have this relationship then of evaporation, which is moving to a vapor, and then condensation, which would be moving back to a liquid. And so the vapor pressure is what the pressure is at that equilibrium of evaporation and condensation. Vapor pressure will increase with lower intermolecular forces because the molecules will be able to move to a gas more easily. We can also then look at boiling point, and this will be the temperature where the vapor pressure of the liquid is equal to the pressure above it. You're going to have stronger intermolecular forces will create a stronger or a higher boiling point compared to molecules with a similar mass. We can also talk about liquids being miscible versus immiscible with one another. This is determined by polarity, and so like dissolves like, so polar will dissolve in polar substances, nonpolar in nonpolar substances, but mixing oil and water, so mixing a polar and a nonpolar substance together, you're going to find that they are not going to mix, and so they will be immiscible with one another. We also see intermolecular forces in solids, and so we can talk about different types of solids and how it impacts things like boiling point. So in a crystalline solid, we have molecular solids, which would be covalently bonded molecules, and we'll find that they have lower melting points compared to ionic solids, which are going to be held together with a stronger electrostatic attraction. We also then have what we would call atomic solids, which are units that are just atoms, and they'll have variable melting points. Just back to covalent for a minute, you're going to have lower melting points compared to ionic, but keep in mind that probably polar covalent is going to have an increased boiling point compared to non-polar covalent, because you're going to have partial charges, and that's going to help to keep it together more and increase those intermolecular forces. Now, if we take a look at atomic solids, what we're talking about are things that are just atoms by themselves. So if we have silicon atoms, well, they might be covalently bonded to one another, so they're going to have a high melting point compared to something like xenon that's just held together by dispersion forces. And so for these, we're looking at just one single type of atom. We can also talk about metallic bonds here. They are going to be solids, and they'll have variable melting points depending on the property of that metal. So we can also take a look at melting point. Polar molecules will have a higher melting point and boiling point compared to non-polar molecules that are the same molar mass. And so we see that with water and methane, or we see that with this methanol and ethane here, where we see that methanol has a polar bond, and so it's going to have a boiling point that is going to be higher than ethane, or in this case, less negative than ethane. We can also talk about our phase diagrams or phase changes that shows the energy and the phase changes. We can look at freezing point, which is exothermic, compared to melting point, which is an endothermic process. So if we look at melting point and vaporization are endothermic. They need to absorb energy to happen. So if you think of this, if you have stronger intermolecular forces, then it's going to take more energy in order to fully melt or fully vaporize. Freezing point and condensation are going to be exothermic, and so this is going to be the release of energy. So if you have stronger intermolecular forces, then they probably want to return to a solid state sooner than something that has weaker forces. We can also talk about sublimation, which is the movement of something directly from a solid to a gas. So if you move directly from a solid to a gas, then that's subliming or sublimation. And if you have weaker intermolecular forces, then you should be able to sublime more easily and at a lower point. Please let me know if you have any questions.